Alright, welcome back. Today we're going to continue exploring surface area and lateral area. Today we're talking about pyramids and cones. Pause the video, write all this stuff down. Alright, so let's take a look. Pyramid is a polyhedron, another three-dimensional figure with only one base. So you can see it only has one base here. And the lateral faces are all triangles. So last time the lateral faces were rectangles, now they're all triangles, you can see. Alright. And they meet at this common point of vertex, so everything collapses down. We have hexagonal pyramids, square pyramids, things like that. We're going to work with mainly pyramids that have a regular shape on the bottom, so regular hexagons, regular quadrilaterals, also known as squares. The altitude is the perpendicular segment from the vertex to the base, so this time it's got to be from that vertex to the base, all right? And the slant height, this is the new one. Slant height is the length of the altitude of a lateral face, all right? And we talk about it in terms of L. So if I have a slant height, I go down this triangle here. It's like on the outside of the triangle, that perpendicular. You can see it right here. It's on the outside of that triangle. If I were to draw this triangle right here, just that triangle, it would be the altitude of that triangle. All right? And like we talked about, a regular pyramid is a base with a regular polygon and isosceles triangles. So all these edges are going to be congruent. All right? And that's the ones we're going to work with mostly. All right, so what's our formula? Our lateral area of a regular pyramid is going to be 1/2 P times L. And again, P is going to be the perimeter of the base. So we have to add all the sides up around the base. And L is going to be that slant height. Now something you need to know about the slant height is not always going to be given to you. Alright? But you can always figure it out. Notice this right here is given a right triangle with the height, the slant height, and half the base. So right here that's the height. And this is going to be the slant height over here. Alright? And you can usually figure out if it's a square, this would be half of this side here. All right. The surface area is going to be the lateral area plus big B, and remember that's just the area of the base. Last time we had 2B, this time just B because there's only one base. Very similar to what we've been doing. All right, so let's find the lateral area and surface area of this one. So lateral area is 1/2 the perimeter times the slant height. 1/2 the perimeter, so I have to find the perimeter. Let's see, I have 1, 2, 3, 4, 5, 6 sides. Each side is 6. So 6 times 6 is going to be 36 times my slant height. My slant height here is going to be 9. All right, so when we work that out, 1/2 of 36 times 9 is going to give us 162. So that's 162, and we have units, inches squared. All right? Again, perimeter times the slant height times 1/2. So now we have surface area. So the surface area is our lateral area plus the area of the base. So we have 162 plus, what is our base? It's a regular hexagon. So we have 1/2 AP. So 162 plus A is our apothem, and that's 3 radical 3. So 1/2 3 radical 3 times our perimeter. Again, this time our perimeter is 36. All right. So I'm going to multiply all this stuff together. Remember, I'm not multiplying the inside the radical, because that's inside, though, that doesn't follow our radical rules, so we can't do that. So I'm just going to multiply 1/2 times 3 times 36, and I get 54. So I have 162 plus 54 radical 3. This is the exact answer, all right? That is the exact answer. If I wanted to get a decimal approximation, I would just put this into my calculator, 162 plus 54 radical 3, all right? And I'll get a, let's say round to the nearest tenth, I would get 255.5 inches squared. All right, so this is exact. If I say find it, that's what I need. If I say round to the nearest tenth, that's what happens there. Now, just so you guys know, if I don't say round, I kind of expect you to give me the number in there. All right, I want the exact. All right, next one, a cone. A cone is a solid figure with one circular base and a vertex not on that base. Everything's pretty much the same. The only difference here is now we have a circle on our base. We still have a slant height. We still have our height from the vertex, all right, and we have a radius now. So the lateral area is going to be pi times the radius times the slant height. Surface area is going to be the lateral area plus the base. We could rewrite this because we can use the specifics. So it's pi RL, which is our lateral area, plus area formula for a circle is pi r squared. All right, so that's our formula. All right. So let's try this one. Find the lateral and surface area. So lateral area equals pi RL. All right, so pi r, well, if this whole thing is 4, then r is 2. All right. And do I have my lateral height? No, I don't. I know this is a right triangle because that's a height. So this is 2. So I'm going to use my Pythagorean theorem. So L squared equals 5 squared plus 2 squared. L squared equals 25 plus 4. L squared equals 29. L equals the square root of 29. All right, now, yeah, is that a perfect square? No. Can I simplify it? No. I don't want you to use this number rounded. Do not put that in your calculator and round it right now. If you're going to round at the end. All right? So now I have this. So 2 times radical 29 is 2 radical 29 pi. All right? Now, if I wanted a decimal approximation, I could 2 times 29. That would give me about 10.8 pi. So this is exact. This is rounded a little bit. And if I said round to the nearest tenth, of course, you'd put 10.8, or I would put the whole thing into my calculator. 2 radical 29 pi, the whole thing in my calculator. Now you got to be careful. Common mistake, putting the pi when you put in your calculator is if you put that pi under the radical, and you don't want to do that. All right. So you want to make sure that you put it in there correctly. And if we put it in there correctly, this would be about 33.8 feet squared. All right. So we're going to use this though for the time being. So let's find the surface area. So we know the surface area is lateral area plus pi r squared. So we have 2 radical 29 pi plus r squared is 2 squared. So now we have 2 radical 29 pi plus 4 pi. Again, this would be our exact answer. If we wanted a decimal approximation, I could add these two things together, maybe make it a little bit nicer, and I get 14.8 pi feet squared. All right? If I said round to the nearest tenth, I would say put that in 14.8 times pi and get my answer that way. All right. So let's try these examples here. Let's find the surface area. So this one, the surface area is the lateral area, 1/2 the perimeter times the slant height, plus the area of the base. That's a regular polygon, so 1/2 AP. So 1/2, my perimeter, 5 sides times 11, 55. My slant height, 14.2. Plus 1/2, my apothem, 7.6. Times my perimeter, again, is 55. All right, so let's multiply those out. This is going to be 390.5 plus 209. Put those together, and we get 599.5 miles squared. All right. It said round to the nearest tenth, and we did round to the nearest tenth. Let's do this one over here. So we have our surface area equals our lateral area, pi RL, plus area of the base, pi r squared. All right. So pi times my radius. If my diameter is 6, my radius is 3. My slant height is 12.4. That's a 4. Plus pi times 3 squared. Multiply this out. We get 37.2 pi plus 9 pi. That gives us 46.2 pi. And then, since we need to round to the nearest tenth, we should get 145.1 yards squared. All right, so that is surface area. See what else we can do. A square pyramid has a slant height of 2 inches. Slant height of 2 inches, that's important. Surface area of 32 inches squared. What is the length of one side of the square base? So let's see, what's our surface area formula? That's 1/2 perimeter times the slant height plus the area of the base. So we have to figure out what is the area of the base. Square base. If I have a square, these are all sides and we don't know, right? So let's see. Let's plug in what we know. We know the surface area is 32. 1/2 times the perimeter. Well, what's the perimeter? I don't know this, but how many S's do I have? I have 4 S's. So 4 S's times my slant height, which is 2, plus the area of my base. Side times side is side squared. Simplify. Half of 4 is 2. 2 times 2 is 4s plus s squared. All right, now we got a quadratic, so we have to solve it. Get everything on the same side as the squared. So I'm going to subtract 32 from both sides and put it into standard form. So 0 equals s squared plus 4s minus 32. Got a factor. Two numbers that multiply to 32 and add to 4 are 8 and -4. So, s plus 8 and s minus 4 equals 0. Set them each equal to 0. So s would equal -8, or add 4, s would equal 4. Now let's talk about this. We have our two answers. Can this side be a negative? Cannot be a negative. That is not a choice that we're allowed to have. The only choice that makes sense is this positive answer right here, so we're golden. All right? Let's try another one with cones like that. A cone has a surface area of 72 centimeters squared, slant height 6 centimeters. What's the radius? So let's see. Surface area equals the lateral area, pi RL, plus the area of the base, pi r squared. Let's plug in what we know. Surface area, 72. Pi. Do I know the radius? No. Do I know the slant height? Yes. All right. So we have another quadratic. Let's get everything the same side. So 0 equals r squared, or pi r squared, plus 6 pi r minus 72. Had to get that 72 to the other side. Minus 72. Let's do we need to say this, 72 pi. I'm sorry. 72 pi. All right. So let's do this here. We got the greatest common factor. We need to take a pi out. So we have r squared plus 6r minus 72. Now we can factor -72 and 6. I believe that's 12 and -6. So r minus 6 or r plus 12 equals 0. Set each equal to 0 and solve. This is obviously going to be r is 6. This is going to be r is -12. Can I have a negative radius? No, so my answer is 6. All right. So stop the video and try these. Great, so let's take a look here. All right, we have a find the surface area. So surface area equals 1/2 perimeter times slant height plus area of the base is going to be side squared. It's a square, so 1/2 the perimeter. 5 times 5 times, or 5 plus 5 plus 5, that's 20. The slant height, do I know the slant height? No. So I have a triangle, I need to find the slant height. I know the height is 6, I know the base, the whole base is 5, so this half is going to be 2.5. So 6 squared plus 2.5 squared equals L squared. 36 plus, well, who cares? Let's just do 36, or 6 squared plus 2, that, put all that in, you should get 42.25 equals L squared. Find the square root, and you get 6.5. So our slant height is 6.5, 5 squared, plug all that in, spit it out, and you should get 90 square yards. All right, let's do this one. Pi RL plus pi r squared. Radius is 11. Slant height 24.6 plus pi 11 squared. So 11 times 246, what is that? 270.6 pi plus 121 pi. And it wants to be in terms of pi, so I got to combine those, and we get 391.6 pi. There you go. All this discussion about pi gave me a little thought of a clip. Some of us are just better at doing math when we talk about pi. Take a look.
Next stop pies. Next stop pies. Next stop pies. Next stop pies.
Let's go, driver. Laverne packs up the pie wagon at 5, so...
At 5? That's only 20 minutes from now. The pie shop is 13 miles away. So at 55 miles an hour, that just gives us 5 minutes to spare.
So wait, when pies are involved, you can suddenly do math in your head?
Hold on, Kevin. How much is 19,154 pies divided by 61 pies?
314 pies.
What if it were salads?
Well, it's the... Carry the 4... And it doesn't work.